Uh, Afternoon. So how many of you have started using Xcode? Xcode 8. Okay, so I believe you're not using iOS 7 anymore. Because when I was talking with friends at the pantry, they were like, I haven't started using Xcode because my project still requires support for iOS 7. What I'm going to talk about is a few new features that would probably help you debug your code faster and effectively. So before we look into the debugging features that are new in Xcode 8, I'll give you a brief introduction to what is debugging, what do we normally do when debugging code and stuff like that. And finally, we'll close with a demo that shows. It's a very simple demo where I intentionally create a retained cycle memory leak and show you how to debug that, how to see, visually see and debug that using the new graph debugger. Okay, so this is very simple agenda. Debugging techniques and tools that you use. Okay, the debugging tools in Xcode. We usually started using instruments way back in iOS 3.4 era, right? But Apple has been bringing a lot of tools that we commonly use in instruments into Xcode. They started integrating profilers, memory stuff, view debugging, and every instrument that you probably use is now a part of Xcode itself, right? And this memory debugging is also one such tool that I'll be explaining shortly. So before we start, I want to start with a quote from a very famous computer scientist, Brian Kernighan. I believe most of you have known him and this code, right? How many of you write clever code? No, I mean, we all have been there before, right? Debugging is what we do most of the time as a programmer. I probably debug code more often than writing, right? And debugging is also complex. It's not easy. It's not as easy as architecting code, or it's not as easy as writing code in first place. Trying to understand your own code that was written 2 years ago and trying to debug itself is hard, right? That's what he says. Everyone knows that debugging is twice as hard, or maybe more than twice as hard, than writing it in first place. So if you write clever code, how can you debug it at all? Right? Debugging can be made easier with help of tools, and based on a wealth of platforms that I have worked with, I would say Apple provided debugging tools, including instruments and Xcode, are probably top notch when it comes to quality. So what is debugging? We all say we do debugging day and night. Every single day we probably debug code, right? Rather than writing and architecting code, we most of the time we spend in our day-to-day office work or freelance work or whatever is debugging, right? I would even go as far as saying that a programmer's skill or ability to contribute depends on how fast and how efficient that person is at debugging. Architecturing the code is important, but equally important is effective debugging. And that requires knowledge of tools. So, what is debugging? Debugging is a process of finding and resolving defects that prevent a computer system from operating perfectly, but right? That's a very boring definition that we all know, right? That's a boring definition I took from Wikipedia, and that's not what I want you to understand. Like, debugging is a systematic process. Debugging is not hacking. Debugging is not playing around with code or making sure everything works. Debugging is a systematic process. This is something you have to understand. We are all engineers. Just how important is writing clean code, debugging in a systematic way is important. So you have to understand that debugging is a systematic process, much like planning how you start your project, planning your complete code architecture and something like that, right? What debugging is not? Debugging is not hacking around with legacy code. Two kinds. I would categorize debugging into two. One is patching code, which how many of you patch code to make sure that your app works? We all do it, right? And the second is understanding what is the defect, understanding what is the problem, and systematically finding the root cause of the problem and trying to fix it, right? Patching is very fast and effective. Anyone can do it. Most companies I've worked or I've consulted with have senior developers, junior developers, mid-range, intermediate developers, and everyone. The good part about patching, anyone can do it. Even interns will probably find it easy to patch code. They just write more code, add more code, and if it fixes, yes, it fixes, commit, send a pull request, right? Most of the time, patching is done by making sure that the probability of this bug surfacing up is low. For example, when you see a code that leaks memory a lot, an easy way to patch it is wrap it around in an auto-release pool, right? It works. Might not be the right way all the time, right? But we all have something called deadlines. Right? So it's easy, anyone can do it, but incurs technical debt. Okay? As you patch more and more code, your debt increases. I'm going to say something that is very polarizing. Don't be afraid of technical debt. Don't be afraid of technical debt. Some technical debt is okay. I didn't say this. Martin Fowler, another computer scientist, he said, there's a post on his website written sometime in early 2000s, saying that he compares technical debt to all the other financial debt that you normally take in your life. Can you buy, no, I'm serious here. How many of you can buy a home without a debt? How many of us can buy a car without a debt? So technical debt is something very similar to financial debt. It's okay to have some, but just make sure that you can pay it off. Okay? Understanding and fixing it is slow, but the right way to do it mostly involves re-architecting parts of code. That doesn't mean that the old code or legacy code was done in a bad, shitty way. It could also mean that when the original developer who architected the code 5 or 6 years ago had a different set of requirements, and then the business pivoted a lot, requirements changed, so the architecture now looks messy, which happens. In software industry, if you have been working, you would always have seen your own code looking bad 3-4 years from now, right? So understanding and fixing is expensive, and not many companies have the money or time to do it. And that's why I say debt is not that bad. Technical debt is okay. Just make sure that you can pay it. Okay? It's not a question I'm going to answer. It's a very subjective question and a polarizing one too. So I'm not going to enter into an argument or something. This is the link to the article that explains what is technical debt and how it affects your debugging, what kind of strategies that you should use when debugging. Okay. Now, comes to iOS. What kind of debugging that we normally do? When we say debugging, what do we normally do? Get rid of crashes, maybe by looking at test flight, crash reporting, crash lytics, whatever. Memory corruptions, performance bottlenecks. My table view is not scrolling smooth. My core animation is not refreshing at 60 frames per second, something like that. Threading issues and layout issues. I'm not sure if I missed anything. I think this is quite a comprehensive list of what we normally do when we say debugging, right? Crashes, stack traces, breakpoints, the normal ways, right? Pretty easy to fix those issues, because when an application crashes, it's probably because the developer assumed something that should probably not be assumed like that, right? Memory corruptions. I always thought managing like debugging memory before ARC was fairly easier than debugging memory after ARC. How many of you agree with me? No one? You have not come across with any retain cycle issues in your this thing, right? Memory corruptions are very usually easier to debug before ARC. At least that's what I think, right? But with memory graph debugging that was introduced in Xcode 8, Apple has done a remarkable job, which I'll show you in a short while. Performance bottlenecks, again, use time profiler. Threading issues. In Xcode 8, there's a new tool called Thread Sanitizer. I don't know if anyone uses threads directly now. I have completely kind of moved to operation queues and stuff like that. Anyone still using threads? Okay, thankfully. No. Layout issues. Again, same thing like memory issues. Before auto layout, fixing layout issues were fairly straightforward. Now with auto layout, it's getting more complicated, right? But we don't have a choice. We have to use auto layout because back before 2012, there was like only 1 or 2 sizes of iPhones, but now there are like 5, 6 different permutations and combinations. We used to use an app called Reveal, but now view debugging is right there, baked into Xcode 7. View debugging has been significantly improved in Xcode 8 as well. But I don't have a lot of time to go through all in this talk. What we'll be looking at is memory corruptions and how to deal with it. Because most others are not new anyway, except Thread Sanitizer. View debugging, if you've been, even before Xcode 7, we've been doing view debugging. Some of you might have used that. How many of you have done view debugging before Xcode 7? Yeah, so not that new anyway, right? So what's new in Xcode 8 in debugging? There's a new section inside your navigator on the left pane called runtime issues. Before that, Xcode just points out the list of compile time issues. But now when you run your application, if there are runtime issues, could be layout issues, could be memory issues, could be leaks, Xcode 8 now lists them as well. We'll see that in a demo shortly. Next is Thread Sanitizer, which I haven't used it yet. I may or may not use it in the future. I don't know. I've kind of every time if possible, I kind of avoid using threads directly anyway. Memory graph debugger. That is a very, very interesting addition, which is what I'm going to talk about now. Now, what is memory graph debugging? Memory graph debugger is a tool that is used if you want to answer this question. Why does this object exist? Okay. When you look at the code, it's all classes and pointers and stuff like that, right? Objects are created at runtime. Some of them live longer than you might expect it to live, right? And you might not always know it. There were command line tools to dump memory and look what the objects were, but 99% of developers that I have met have not used them. Memory graph debugger is built on top of this and makes it super easy to understand what is going on behind the scenes at runtime. Memory debugging has changed significantly before ARC and after ARC. Before ARC, your static analyzer was pretty good at spotting out your memory leaks, spotting out whether you've missed any retains or releases and so on. But we live in a post-ARC world. I haven't seen any any manual reference counted code in the last 2 years. I believe most of you are like that as well, right? Which means we have to learn tools that will help us manage our memory effectively in this post-ARC world, right? Before ARC, your memory issues were mostly leaks. Instruments helps us a lot at runtime. Static analyzer is brilliant, and most of these issues were also quite easy to fix. Most of the time, your problems were in one single file, right? You leak memory and you create something in viewDid load, you forget to deallocate it in dealloc or viewDid unload, and so on, right? But after ARC, not so straightforward, right? But ARC has benefits, which is why we live in a post-ARC world now, right? Mostly retain cycles, difficult to fix, but not anymore. You can avoid retain cycle by following principles, but that you will have that luxury only when you architect and you write the complete code, which most of us don't have that luxury of doing, right? Before memory graph debugging, I always felt ARC was like 1 step forward and 2 steps behind. Like, it made writing code a breeze, but it made debugging someone else's code that has retain cycles significantly harder, right? A few days ago, some time ago, one of the developers of Instagram posted a retain cycle with 15 nodes in the graph. And I was like, okay, wow. Instagram has leaks, so I'm fine. I can have bigger leaks than that, right? But see, like before ARC, right? When I write code, I usually run static analyzer, and I make sure that I treat every analysis issue that I see as a warning, and I tend to have zero static analyzer issues before I submit the app to App Store. But not possible anymore with ARC, right? So ARC expects you to write code without retain cycle, which is not that easy. Retain cycles, theoretically speaking, most blogs, including Apple's own developer side, they always like, if A retains B and B retains A, that's a cycle. That cycle is very easy to understand, very easy to fix. But most of the time, cycles are not like that. Cycles are always like 5 to 10 different objects referencing each other in a cyclic fashion, right? And that's why you need a tool like Memory Graph Debugger. So I'll start with a demo, but my demo is simple because I want the demo to work when I'm presenting. So I don't want to have a very complex demo that doesn't work. So very simple, 2 view controllers, parent view controller, which is in orange here, and the child view controller, which is in green. I have a button that just shows that view controller, and that's it. When you run it, it looks like this. Very simple. This is something that you would have show child. It shows the screen, close, it closes. That's all. Very, very simple application. I'll walk you through what the app does. The parent view controller has a property called child view controller. I'm just retaining parent and child retains the parent. That's all, right? And child view controller has allocates a 10,000 sized array just for the sake of it, and retains it, right? This code has a retain cycle. Why? Parent retains child using a strong reference. The child retains parent using a strong reference. Right? Now, let me run this for quite some time. I'll just show and dismiss the view. Show, close, show, close. I'll do it 3 or 4 times. Now, in Xcode 8, I have a new tool here. Okay, the first one is view debugging, introduced last year. This is simulation of location, which was there for quite some time. Next one is graph. This one is to show the memory graph. When I click, let's see what happens. I see something called, I have 20 leaks as shown by the info panel here. Then I see something called child view controller, 3 instances, and it all looks like this. Now, child view controller, every time you open memory graph debugger, the moment you see a cycle, that is a leak. The moment you see a cycle like this, something is wrong somewhere. Okay? Before memory graph debugger, you didn't have a visual representation of what is going on in your project. I'm actually pausing the project, pausing the execution of the app, and showing this graph in real time. Right? So, child view controller maintains a strong relationship with a closure that captures another closure that again retains the child view controller, and this is a loop. And memory graph debugger is not without its own set of other problems. It says there are 20 different leaks, but in fact there's just 1 or 2. To me, it sounds like a false positive, and to me it looks like under UIKit, I see a cycle of 15 different or 10 or 15 different objects in a cyclic loop. You have to learn to ignore this. You know why? No, it's. I'm not saying that UIKit has problems. It's more like because you are leaking memory graph debugger does not know whether it's your code that is problematic or whether it's UIKit that is problematic. It just shows every possible retained cycles. But this retained cycle is a byproduct of the retained cycle that you created. Okay? So how do I fix it? Like real quick, I'm going to add weak self just so that this closure doesn't own it, and then I'm going to make my parent view controller weak as well. This is how you fix memory retained cycles, right? Fixing it is easy. Spotting it is hard. But now that my memory graph debugger showed that there were some closures that were pointing it back and forth to my child view controllers, I can kind of narrow it down to where it is. Now if I run it, the same application, and okay, close, do it 3 or 4 times, so you have some. Now if I open graph debugger, I don't see any leaks at all. It's all like straightforward. If I open my child view controller, it doesn't open. Okay. There's no cycles. See, my child view controller, there's no cycle, there's no circular reference anywhere. And that means I'm good, right? And if you look at the left pane, there is no UIKit cyclic references as well. That means UIKit was actually, didn't have any problems. It was your code that internally caused UIKit to have that cyclic reference and not UIKit that was buggy. Most of the time what I see is, oh, UIKit has 15 node retained cycle, whereas my code has only 3. I'm going to ignore that for a while. No, it's not always like that. UIKit is at a level that is deeper than, it sits below your architecture. So if your code leaks, obviously UIKit will be leaking, right? Back to slides. So any disadvantages? My computer is 4 years old. I'm waiting for the Apple event. Loading memory graph for a project that was this small took me about 5-10 seconds, right? I tried it on a MacBook Air. If you have an air conditioner at home, it's okay, but otherwise, you have to make a choice. You can have a MacBook Air, or you can have a beautifully loaded memory graph, okay? But just like any other Apple tool, last year with Xcode 7, when Apple introduced view debugging was significantly slower than Reveal or any other third-party tool that was available. But view debugging in Xcode 8 is significantly faster. Apple claims it's about 70% faster. Maybe loading memory graph would improve in Xcode 9, I'm not sure. I'm just going to wait. That's it. Questions?
Okay, any questions? This is a new tool. Anyone has any questions or any okay, sorry.
I noticed that it shows you that a closure has captured your variable. Right. But does it give you any other hint? Because generally,
this thing no other hint. I tried double-clicking the closure to see if Xcode will automatically highlight that line in my code, but unfortunately for now, it doesn't do it.
Because usually your retain leaks will often be closures, so it's quite hard for you to find.
What's it?
Your retain cycles are usually often caused by closures. So it's going to be quite hard to find if you can't pinpoint the exact closure.
Yes, in a project that has a massive view controller, yes, but if your code is quite organized, I think it should be fairly straightforward to pinpoint where the cycle is. The problem with memory debugging is knowing that you have a retain cycle, right?
Okay.
Hi, are you able to build this into a DevOps pipeline?
Can you repeat that again?
Can you build this into a DevOps pipeline? Can you automate it?
Can you what?
Can you automate it? Build it into a DevOps pipeline?
There are command line tools, but I'm not sure. I haven't done anything like that before. This whole memory graph debugger was built on top of the command line tool that existed since a long time, but yeah. You could, but I haven't tried it.
Okay, thank you.
Before we have I noticed that to detect the retain cycle, we usually have some like a flag at the linker flag, something like that, so that it will detect, oh, this one is prone to retain cycle or have retain cycles, and is it provided in Swift 3, Xcode 8, or like we have? To detect it, it's much easier, right, to use the retain the flag for locating the exact code that has the possibly retain cycle. So is it helping or not?
It helps to some extent. Like you saw that the code that I wrote, very simple code that had a retain cycle across 2 different classes. Most of the Xcode linting tool or static analyzer can help you detect retain cycles that happen within your same class. But in this case, my retain cycle was between 2 different classes, which the static analyzer or the compiler doesn't show it as an error or warning. And that's why you have to use tools like this. And in projects that are bigger than this, which with like hundreds of classes, this tool is very useful to know why an object exists and who is retaining what, and the complete memory graph of your running application.
Okay, thank you. That explains.
Any more questions? Okay.
So the cycle only shows up when you click around. And it shows 20 cycles, like 20 leaks or something, right?
It shows 20 leaks,
Yep.
but it shows one cycle in your
Yep.
code.
Yep, sorry, 20 leaks. So what? If you have a huge app, do you have to open it up and click around everywhere?
No, it's just like debugging where like the issue navigator actually shows issues and leaks from all frameworks and all running.
Yep, but you must cause the leak first, right?
Yeah, but you have to focus on leaks that appear on your code and fix it. Most of the time, that will fix everything else.
Okay. Reason I'm asking is because then you usually enter the testing phase where you have to touch every part of your app and then watch for leaks. It seems like a lot of effort.
Right.
Okay, any more questions? Am I missing out? No, okay, not missing. Okay, thank you, Mugunth.